How to reconstruct your data.
Manually, when your automatic reconstruction has failed or has not produced a result that you like.
Exactly. So the data set I'm going to pull up is cryptoglanus soft tissue scan, but it works the same with the skeletal scan. So browse for your input file. The first thing I'm going to do is open this segment because I already reconstructed it. And as you will see, you have to use the same byte scaling for every segment. When you already have something reconstructed, you can open the raw data and it will automatically have the same settings that you used. So you have your reconstruction settings over here that it used, and on this tab, you will have your byte scaling settings that you used as well. So I chose 0 and 0.41 for the first segment of the scan, and then we are going to use the same for the next segment. So I'm going to open the second segment of the scan. You can see your data over here, and you can drag this slider around. This is important because you're going to need to find the areas of highest density for your byte scaling, and you want to find the otoliths, and sometimes the otoliths are not visible. In this case, they are visible at this angle a lot more so than the other angles. But that is for later. For now, we're going to do center shift. Even though this has automatically found the center shift, sometimes if the reconstruction doesn't go through at all, you have to find this yourself. So change this to auto center shift. Come down here. I always do something like -5 to 5. It will automatically change the step size. And then you hit search reconstruction. I'm actually this time going to do a smaller window because we already know that the computer says it should be around -2.8. So I'm going to do -3.5 and something like 2. That way our step size is smaller and we have more control over which center shift value we like best. And hit start.
It's getting bad info from the engine.
Band info.
Bad info.
So I paused the recording, but it goes through a series of steps, and then no, I'm recording again, and then it will automatically go through these slices. And then when it's done, it says it's done, but it's lying, and it's not really done. You can click through here and find your best slice. Best center shift value that makes everything aligned. Just going to pause it again while it thinks. So the auto center shift is done. Now kind of looks crazy and overexposed. You can't really see detail. So what you want to do first is go down here to the histogram, open that, change it to full range. You could change it to your custom actually right now. And since we know it's going to be 0 and 0.41, we can go ahead and apply it. That's what our final byte scaling looks like. So we might as well do that. You can click log to see what your data looks like. And we already checked the first segment in Dragonfly and it looked fine. So we're going to keep those numbers. Right, so focus in on some structure. here. And then click through different values and you see it become better and then become worse. Now it's becoming worse. So you would go back. So right now we're at -1. It's better. 2.3 is better. 2.5 is even better. So we actually missed the value that the computer found. But it's the best one is somewhere near that value. Let's see. Maybe, maybe not. Maybe the best one is actually somewhere. No, I'll go back. It's hard to say. I'm gonna take that. But I'm actually going to not take it. So if you want to take your manual one, you have to click use current slice recon settings and it will replace this one. But I'm actually going to keep this one because I think it might be better. So that's how you find your center shift. You can do it again. You can do it manually. You could say, and the manual part of it is you choose the step size. So this auto one has a set number of slices that it'll do. So whenever you change your start and end, it'll change a step size based on the, I think, however many it does. Is it 14, I guess? But on manual, you could do these numbers and say you want a step size of points, this value, and you'll have a lot more than 14. That makes sense. Okay.
So would you check that the automatically reconstructed center shift again with the smaller kind of range?
Yeah.
And smaller step sizes?
Yeah, you can. And you can basically spend a bunch of time doing that, finding the correct one. Let me go back. Yeah. Right, so I'm gonna keep this. Real quick, you have to save, you have to tell it what to name it and save it somewhere. So I've made a folder on this data drive called cryptoglanous iodine. I already have this one, so I'm gonna name it the same, but this is the second segment. Click save. You have to save to the computer. I'm pretty sure you can't save to a hard drive. I think it will fail. So if you had chosen a hard drive as your location, I think the reconstruction automatically fails. We're not going to do any of that. We are going to drag down to the otoliths and then show how to do byte scaling. So the otoliths are there, at least one of them. And then we go over here to reconstruction settings. And this will take a little bit of time to update, and it should show you the slice that you've chosen with this line. But if it doesn't, you just have to drag it again. Sometimes it just shows you the middle automatically. All right, so this has popped up and we can zoom in, find our otolith, which is here. Once again, we want to, well, we don't know yet. Well, we secretly do know, but we don't know what our byte scaling is going to be. So the way to find out what it needs to be is to use the line graph tool. Cool. So click that, drag a line through the densest and some less dense structures. Then this pops up and you find your peak. You can drag this red thing and it makes this little tiny black dot that's almost invisible move, and you can see where you are. So of course at this highest density is in the otolith. And that number is 0.35. So what you want to do is your maximum value should be this number plus a tiny bit of wiggle room, because if you make it this number, that's your whitest white, and the otolith will be completely white with no gray values. And you don't really want that. You want a little bit past it, so it's not just completely white. And earlier for the first segment, I picked 0.41 after playing with it a bunch of times and seeing what looked best. And 0 you can use for the minimum, although a slightly negative number sometimes looks a little bit better, but in this case it looked fine to use 0. So before you commit to your numbers, you can open histogram again, logs, you see how your numbers change your data. Custom range is what you want. I want to do 0. And I want to try, let's say we tried that 0.34. Hit apply. Boom. So now your otolith is the whitest white. In your black, your lowest density is fully black at 0. We can zoom in and see that the otolith, it's like overexposure when you take an image. So this overexposure is a bit much. I'm going to change it to 0.39, and then watch what happens not only to this but to the data. It scrunches in a bit, but you actually have detail in your otolith, which is what you want. So what changed? I'll do it again. 0.3, let's say 3.3, is you'll see that this data gets stretched out. But you're actually losing stuff here. So let's try 3.9 again. And then you have gained that back. So what I did was 0.41. It's somehow, in a way I can't fully explain unless it just changes the scale, seems to not only add this little bit of data at the end, but kind of almost gives you a higher, I don't know how to explain it, but it's a higher quality image. Your gray values haven't really scrunched together too much, so you're spreading these values out over the data, and it just looks nice if you look back.
Oh, wow.
Thank you. Yeah, so you can play with it a bunch. If you do negative 0.009 or something like that, you can see how the data changes. You get this peak here. Earlier that peak is smashed up against the y-axis, so you can't see it. And just, you lose a little bit of data because your data gets scrunched together in gray values, but the image is almost a little bit nicer. That's hard to say. So I'm gonna leave it at 0. Right. You have to change byte scaling here from global to custom and use those numbers you just found. Then you should double check before you do anything that your beam hardening correction stays at 0.05, the recon filter stays at 0.5. The center shift should be that value that you found earlier. Just double check it. Everything else stays the same. We don't do any of that. We don't bother with despeckle or secondary reference. We don't do nothing else. So you're actually ready to reconstruct, and all you have to do is hit start, and it takes about 20 minutes. So we hit start. and let the computer do its thing, and then you have to stitch. How to stitch. All right, the reconstruction is done. Now we can do stitch. Open stitch. Hit this button. Find your manual reconstructions. Shift, open both. Right, at this point, if you have messed up and you have the incorrect something somewhere, you'll get error messages here. Like if your byte scaling isn't the same. Your center shift can be different. And it will be different almost always. But this is the byte scaling has to be the same. Now you have to browse and choose where you're going to save this. And I'm going to save it in the same spot. And stitch. At this point, I would prefer to also give it the other information. So at least the voxel size, 2.36. And probably the scan number, but I'm not going to worry about that now. So I'm just going to save this. Once again, you have to, I think you have to do this in the computer, not a hard drive. And then hit start, and it takes about 30 minutes for a 3-part scan and maybe 25 minutes or so for a 2-part, maybe 20 minutes. And this will go on for a while, and you will have your stitch. The end.